Great. Yeah, it's 8 a.m. Mountain Time, so we're good to get started with our very first Discord talk and Q&A, our very first community call. So welcome to everyone joining. It's great to see you here. And today we've got Kobe here with us from the PowerSync product team. So Kobe will be taking us through, what the team's working on at the moment, including the support for additional frameworks like React Native. And he'll also share some of the latest features that have recently been released. With that, I think I can give over to you, Kobe.
Okay, great. I'll briefly just wave hello. I'm Kobe, and I work here at the PowerSync product team, closely with engineering, quite technical product management here. I thought I'd start by just sharing some insight into what our current priorities are. One of our big priorities at the moment is just supporting existing users. PowerSync is being used in production, and it's ready to use in production for Flutter on the front end and Supabase and self-hosted Postgres on the back end. PowerSync runs on enterprise-grade infrastructure, which is wired up to around-the-clock Opsgenie teams and schedules. We've got a globally distributed team. Some of our existing users are kind of reliant on that high bar of support. Helping existing users deploy PowerSync is a big priority for us. Another big priority for us is adding support for more technologies. For now, we're focused on additional front-end technologies. One of the big ones we're working on right now is React Native. In terms of existing users, what I'll cover a bit later are some of the dashboard enhancements we've got, and also some updates we're going to be making to our docs. New platform SDKs, I'll cover that. So today, we launched with Flutter, kind of standalone, but one approach would be to kind of brute force and just build additional PowerSync SDKs for all the platforms, which is very much like an end problem. And that would obviously be quite a large engineering undertaking. And so we decided to approach it a little bit kind of like trying to have more leverage with less effort. And so we decided to investigate having some kind of common core where we could have the bulk of the logic ran on the client side for synchronization. And we did some POCs and we figured out a way to actually do this. And I'll be sharing a bit of the architecture of what that looks like today. But with the common core model, it's more of an adapter-based model where we've got the core sync functionality in the common core with more thin layers for each platform that we want to support. So to give you a bit of insight into how it works, I'm actually going to start by just explaining in the Swift realm. Doing a bit of work on Swift at the moment, but we're really focused on React Native. But the concepts are kind of easy to explain in the context of Swift. And then I'll show how those concepts apply to React Native. So today, if you're a Swift developer and you want to use SQLite, you kind of pull in the SQLite library, which is C-based. There are some C bindings which let you make the SQLite calls from your Swift code. And we would have this PowerSync Swift SDK, and then the Swift app code would use that. Instead, what we're doing is we're building up a Rust SQLite extension, which is Rust-based. We can then implement a Swift SDK, which is much thinner. So really, we've moved a ton of the complexity from that native Swift SDK into common Rust library. This is all just like the architecture we're taking. So we've moved, in terms of lines of code, this moves about like 50% of the code into the Rust common core, but that 50% is some of the most complex code. So this is a big win because if we look at from a developer experience perspective, you're simply going to add the PowerSync SDK to your project and use those APIs. So it's more going to look like this. That's really the big architectural change we've made coming from the Flutter-based SDK, which was almost purely standalone, here to the new architecture. For React Native, pretty much looks exactly the same. We've got the Rust libs. We then use JSI bindings, which are like JavaScript interface bindings. There's a thin JavaScript SDK on top of that with an additional JavaScript React SDK on top of the JavaScript SDK. So this is pretty much the architecture that we're going with for our React Native SDK. And the nice thing is that for web, it looks more or less the same. We can take that Rust lib into WASM. We have JS bindings instead of JSI. There's a vanilla JavaScript SDK, and there's a React SDK. And so that's coming down the road. But yeah, the big one for us here is really that we're using this common core, which is Rust-based, which helps us a lot and encapsulates most of the very complicated sync logic. So we don't have to rewrite it for each platform and maintain it and upgrade it. We can just do that in one place, which really enables us to move faster. And then for the platform-specific SDKs, whether it's web or React or React Native or Swift or Kotlin, those are going to be much thinner, and we're going to aim to keep those open source as far as possible for a bunch of reasons. Yeah, we're looking to have React Native available in 3 to 4 weeks. Got a bunch of people very keen to start testing that. Keep an eye on Discord, and for sure we'll be announcing that once it's available. Okay, that's it in terms of the SDK, the update on the SDK side. What I'll be covering next is some of the recently released enhancements we made to the dashboard. One of the big things that we added are deploy logs. So when you update connection details or update your sync rules and you deploy those, you can see those in the deploy logs panel. We've also added validation. So when you're editing your sync rules, there's a validate button in the top right. If you click that before clicking deploy, it will actually run validation checks directly against your database. So in this case, I introduced a typo here, adding extra S on to-dos, and then the validation failed. So yeah, that's definitely a useful tool. We also, there's a bit of autocomplete in the sync rules. So hit Control Spacebar and you'll get some autocomplete, which can help you write those bucket queries. In terms of priorities for the dashboard, the number one priority at the moment is better observability, primarily exposing any replication errors to users in the dashboard. So if PowerSync failed to replicate from Postgres, then actually exposing that as an error. We also want to expose client sync operations and errors to give you a bit of insight into the devices connecting to the cloud service. And in the future, if you're making big changes to your sync rules, that can incur some reprocessing, and just giving you some visibility into how that reprocessing is going. In terms of our docs, a big gap we're aware of at the moment is just in terms of having more example code. There are lots of things that are possible with PowerSync, but we don't necessarily have all of them documented. So big things that we want to that we're working on adding are, examples of doing custom conflict resolution, how to handle errors, perhaps with the upload data call. Sometimes you might want to merge records, having examples of that. Custom auth is something we're working on, and also just examples of how to do data upload calls. And yeah, that's it, Philip. That's the update from my side. I think we could move to Q&A now.
Okay, great. Yeah, thanks, Kobe. Thanks for covering the work that is planned. So because we're following an approach where we're using this common core, the work to support additional SDKs is slightly reduced. So that means we should be able to ship support for additional frameworks in shorter and shorter time periods. Is that right?
That's right, yeah.
Okay, great. Thanks very much for everyone joining again. Have a good rest of your day. And yeah, we look forward to the next call, which should be soon. All the best, everyone. Cheers.